15th. All right. Good morning again. I guess we could start. I don't see who is the missing person. Okay. Miss Fabian. Let's see her.
Morning, everyone.
Good morning. Okay, good morning. Okay, so Fabian is out. So yeah, 1, 2, 3. Okay. Now today, I'm not sure I responded to all of you, but I did get the homework and the makeup quiz. I'm going to send that makeup quiz result to you sometime this weekend, and you're supposed to get another quiz today, but I'm going to do that as a sort of take home because we have quite a bit to cover today, and I want to see if we could keep on track as best as possible. So I'll give that as a take home. Are you all hearing me?
Yes.
Yes. Okay. Yeah. Okay then. Yeah. So for today, we're going to continue in chapter 5, and I'm trying to see if I could cover 2 sections of 5.2 and 5.3. Okay, and 5.2 deals with integers. 5.3, sorry, 5.2 deals with integers and order of operations. And 5.3 deals with rational numbers. So far we have looked at the whole numbers, or what we call, sorry, not whole numbers. We looked at counting numbers or natural numbers. Okay, that's what we were looking at when we were dealing with sets, the set of natural numbers. Anybody remember what distinguishes natural numbers? What's the first natural number? Miss Nairn, what's the first natural number?
1.
1. Okay. And so it goes 1, 2, 3, 4, 5, 6, and that's an infinite set. We also had looked at other types like prime numbers, composite numbers, and I did mention whole numbers. And the whole numbers would be the set of natural numbers with a 0 as the first number. So whole numbers would start with 0, 1, 2, 3, 4, 5. So the only difference between the whole and the natural is that whole numbers include the 0. And of course, you know, even numbers, odd numbers, and of course, like I said a little earlier, prime and composite. So those are the types of numbers we have looked at so far. So this morning, we're going to extend our number sets to look at the set of integers, which is on page 238 of your text, if you have the text. And integers, you will see from the screen, would include negative numbers, positive numbers, and 0. So basically, we extended to include negative numbers. All right. Now you'll see that it says you could use a plus sign to indicate that a number is positive, but you don't have to write the positive sign in front of positive numbers. Okay. So the number by itself is considered to be positive. And of course, definitely though, for negative numbers, you have to indicate that it's negative by putting that minus sign in front of the number. So a number without a sign in front of it is considered to be positive. And I think most of you should already be aware of that. Okay, now a useful tool that we often employ when we're dealing with integers is the number line. The number line is helpful when we are looking at integers because with the number line, we can show relationships between different types of numbers or different numbers in the set of integers. We could also use it to graph results for problems that we are solving using integers. All right, and you'll notice here that it says the 0 is neither positive nor negative. It's considered neutral. So to the right of 0 is positive, to the left of 0 is negative, but 0 is neither positive or negative. Okay. Let me see. Fabian, she didn't receive the link. No, I didn't send out a link. How did y'all get onto the class? Because someone is asking about link. Did y'all get a link this morning?
No, we used the old link.
Okay. All right, let me let her know. You have to use the old link from the previous classes. I didn't let me say that again. You have to use the old link from the previous classes. You have to use the old link from the previous classes. Just trying to send a message to someone. Okay, so here we have a number line showing.
Good morning.
Good morning. This is Miss La Rochelle.
Yes, sir.
Oh, okay, you made it. Okay then. Yes. So they don't send links out, so just it's the same link for every class.
Okay, no problem.
All right. So here we have a few numbers, and we are asked to graph the results. A is -3, B is 4, C is 0. And so when we are asked to graph numbers on the number line, basically we just use a dot to mark the position. So for A is at -3, you'll see the green dot showing where A is. So that's the graph for -3 or the position of -3. Of course, 4 is positive, so it would be to the right of 0. And C is 0, and that's marked with a green dot as well. Okay, so that's a very basic exercise asking you to put a dot to indicate the position of each of those integers on the number line. So I'm going to do a quick one here. So we have three numbers, -4, 0, and 3. And Miss Pratt, you want to tell me where to put that first number? Where to put the dot for the first one?
You can put it by the -4.
Okay, so you make sure to put it right there where the -4 is. Okay. Miss Nairn, where we're going to put the dot for B?
On top of the 0.
Oh, oops. Okay, I'm gonna put that right there. Miss La Rochelle, where are we going to put C?
Top of 3.
Okay, that's right here to indicate. Okay, and so we could label that one A. This one would be B, and C. All right. So when you're asked to graph numbers on the number line, that's basically what you would do, indicate where on the number line the number falls. Okay. So moving on then, we also can use the inequality symbols with integers in the same way we could use them with natural numbers. So if you look at the graph below, you will see where they have identified -4 and -1 on the line. And it says, observe that -4 is to the left of -1 on the line. So as you move further left on the number line, the numbers are increasing or reducing. Miss Fernanda.
Decreasing.
Okay, decreasing, that's Miss Pratt. Okay, so Miss Fernanda,
Increasing.
what happens as we move to the right on the number line with the size of the numbers?
They would increase.
Increase, okay. So that's one way the number line can be useful because it helps us to see relationship between integers. So as you move further to the left, the number decreases. As you move further to the right, the number increases. So when you have those two numbers highlighted there, -4 and -1, you can easily decide that -4 is less than -1 because -4 is to the left of -1. And so you'll see that they put the symbol here, less than, to indicate that -4 is less than -1. Now, if the number is to the right, so in the case, if you change the order like what we see here, -1 came first, -4. Now -1 is to the right of -4. So that means that -1 is greater than -4. Okay, so the position on the line helps us to determine what the relationship between two integers are, whether one is greater or one is less than. So if it's greater, it would be to the right of the number. If it's less than, it would be to the left of the number. Okay, so the numbers that are to the far left are decreasing, and as we move to the right, the numbers are increasing. Okay, so we're going to move to look at this example here. So we have -4 and 3. Is -4 less than or greater than 3?
Less than.
Less than, because it's to the left of 3, so it would be less than. Oops. Oh, I thought this thing had the answers. Oh, okay. All right, they give the full answer on this side. Okay. All right, so -4 is less than 3. What about -1 and -5?
-5 is
Negative
less.
greater than.
Well, we're keeping it in the order that they have. -1, is it greater than -5 or less than -5?
Greater than.
Greater than, because -1 is to the right of -5, so it is greater than. Okay, -5 and -2. -5, is it greater than -2 or less than -2?
Less than.
Negative.
Less than negative.
Okay, it's less than -2. -5 is less than -2. Okay, what about 0 and -3? Is 0 greater than -3 or less than -3?
Greater.
Greater. Okay. So the answers are shown here, and they give the explanations for those. And it's all a matter of which position the numbers fall relative to the other on the number line. Okay. So if you're not sure, using a number line is helpful to help you decide which of two numbers is greater or less than. I'm going to skip this one because, yeah, okay. All right, so we also looked at the symbols here that could include equal to. So you see A is less than or equal to B. We did that when we were looking at sets. B here is greater than or equal to A. All right. So when we have that symbol, it means that the one value could be equal to the other. And so when a symbol like that is included, then you know the number at the beginning and the two numbers could be equal. Okay. And so that's what that particular inequality refers to. One number could be equal to the other in the first case, but it have to be less than or equal to. In the second one, it could be greater than or equal to. So we're going to look at next what is referred to as absolute value. Now, on the number line, everything is in relation to its position in terms of how far it is from zero. So when we talk about absolute value of a number, we're looking how far is this number from zero. Okay, and because the absolute value is telling you how far the number is from zero, it is not a negative number, it's going to be positive. So in the first one that they give you here, and you see how it's written with the number in between these two vertical lines. So they're asking for the absolute value of -3. Basically, they want to know how many spaces from 0 is -3. And if you count from 0 to -3, it's 1, 2, 3. So the absolute value of -3 is 3. The next one is asking for the absolute value of 5. So how far is 5 from 0? You count 1, 2, 3, 4, 5. The absolute value is 5. And of course, the absolute value of 0 is 0 because you wouldn't move from 0. So the absolute value is 0. So the absolute value is useful when we have to do operations with integers. And so we're going to see a reference made to that a little earlier. But once you see that term absolute value, it's written with the two vertical lines between the number. It's basically asking you to tell how far is the number from 0, and the result will always be positive. It will not be negative because you're just telling distance. Okay, so this is just the answers for what we just looked at. And so let's look at these.
Miss Allen, 1 second, please, because I looked at your first example. The -3, you said that we're not supposed to put the negative there. We're just supposed to just put 3, right? Oh,
yeah,
3 units. Okay.
Yeah, the absolute value is just telling you how far the number is from 0.
Okay.
So the answer is just 3. Okay. And so the explanation is given right here. The absolute value of -3 is equal to 3 because -3 is 3 units away from 0. All right. And then the next one, 5, the absolute value of 5 is 5 because 5 is 5 units away from 0. And the third one, the absolute value of 0 is 0 because 0 is 0 units away from itself. And so it's always going to be a positive result when you ask for the absolute value. All right, so in these examples here now, this checkpoint 3, Miss Fernanda, what say you about A? What's the answer? Miss Fernanda?
-8.
Okay, we want the absolute value.
Sorry,
How-
I
I didn't hear you.
no, I said sorry. I actually stepped away, and as soon as I
Okay.
came back, you called my name.
Okay, so
It's equal to 8.
8, right? So -8, the absolute value is 8. Okay, so it's always a positive result.
Okay.
Okay, Miss Pratt, what about the absolute value for B?
6.
6. Okay. Miss Fernanda, what's the absolute value? Well, what's the answer for C?
+8.
That one is a little tricky because they're asking you for the negative of the absolute value. The negative of the absolute value.
Oh, negative 8?
Okay. So because they're
Oh, I was
asking
thinking
you,
that was like
yeah, so we have to look out now
would
for,
it be negative 8?
if it wasn't that minus sign in front of it, then it would be 8. But because they have negative of the absolute value. So this first one, the A was negative 8 absolute value. The answer is equal to 8. But in the last one, they have the negative outside of the, the vertical lines. So while the absolute value of 8 is equal to 8, because they have that minus sign in front there, then it's going to be equal to negative 8. Okay, so C is equal to negative 8. Okay. All right. Now, addition of integers is something I think most of you would have done some time ago when we talk about adding negative and positive numbers. Okay. And so we should be doing a sort of review here. Now, in your book on page 241, they go through some kind of a rule system for adding negative and positive number. And so the first rule they have there is that if the integers have the same sign, you just add their absolute values. And so that's where the absolute comes in handy to know what the absolute values are. So in this example that they give you, you have these two numbers to add. The first one is negative 11. The second one is negative 15. And you notice they put the negative 15 in brackets. So both of them have the same sign. So once they have the same sign, you just add their absolute values, which would be 11 plus 15 in this case is 26. And you give the answer the common sign. So because both of them had negative, the answer would also be negative. Okay. So that's your rule for adding numbers or integers that have the same sign. So those are two negative numbers. So the answer will be negative after you add the absolute values. Now, if the integers have different signs, then they say you have to subtract the absolute values. And once you subtract the absolute values, the sign is the same as the sign of the number with the larger absolute value. So that's the rule there for when the signs are different. So in this second example, you have negative 13 plus 4. So the first number is negative, the second number is positive. You're adding them. So you're going to subtract the 4 from the 13, you get 9. And then the answer gets the sign that the large absolute value had. So the large absolute value was 13 and it was negative, so the answer becomes negative. They have another one here, 13 plus negative 6. Okay, 13 is positive, negative 6 is negative. You subtract. 6 from 13 is 7. Since 13 was the large absolute value, then the answer would be positive. So whichever number has the larger absolute value, if it was negative, your answer would be negative. If it was positive, your answer would be positive. Any questions with that? No? Okay. Now, of course, those rules are helpful, but for you at this point, you'll be allowed to use your calculator to do these calculations. So while it is helpful to know the principle, you should also be aware of how to use your calculator to derive these answers or to even check your answers. Okay, so if you have a scientific calculator, you will see some of those calculators have this, this symbol right here that I'm circling to allow you to change the number to negative. So it depends on the calculator you have. So some scientific calculators, so this one here is telling you how to do it using a scientific calculator. So we're doing this here in -11 plus -15. So in some calculators, you have to enter the 11, then press the plus minus to change it to negative. Then you press add, then you press the 15, then you press the plus minus to change that to -15, equal, and you get your answer. Okay. Some calculators actually have a negative sign like this. So you could just enter it just as it is written. You press your negative, you press your 11, you press your plus, you press your negative again, you press your 15, and you press enter, and you get your answer. Okay. So I would suggest to you, because calculators are different, that if you plan to use a calculator to do these types of questions, that you practice with your calculator, look at the manual to see if you can figure out how to work it and which one is the negative sign. And they give you 3 examples here. So this first one is -11 plus -15 equals -26. The 2 signs are the same, so you're going to add them. The answer has the same sign as both of them. In this second one is positive, one is negative. So there are different signs. So you're going to subtract. The answer gets the sign of the number with the larger absolute value, which is -13. And in the third one, again, we have 2 different signs. You're going to subtract, and the one that has the larger absolute value is 13, so the answer will be positive. So what you could do, you could try these 3 out on your calculator, see if you get the answers that's there, so you could know how to use your calculator keystrokes to derive the correct answer for these types of calculations. Okay, so depending on the type of calculator you have, determine how you will process questions like these. All right. Now, another term aside from absolute value that's useful when we're dealing with integers is what is referred to as the additive inverse. Okay. So it says additive inverse have the same absolute value, but lie on opposite sides of 0 on the number line. When we add additive inverses, the sum is equal to 0. So for every number except 0, there is an additive inverse. So if you look at number 1, 18 and -18, those 2 are additive inverses. When you add them, you get 0. In the case of number 2, you have -7 plus 7. -7 is the additive inverse of +7. You add them, you get 0. So you can find the additive inverse by simply looking to the of 0 on the number line, the same number of places, and you will find additive inverse. So you should be able to just figure it out by changing the sign of the number you have. So if I give you 24, then the additive inverse, of course, would be -24. If I give you -100, the additive inverse would be +100. So that's what we mean by additive inverse. It's just the inverse in terms of the signage of the number. And when you add 2 additive inverses together, you get 0. And that concept is useful when it comes to subtracting integers. And so we're going to look at that right now. Okay, so it says for all integers, A and B, if you're asked to subtract B from A, it is the same as adding the additive inverse. And that's what they're showing you here. So you could rewrite A minus B as A plus minus B, adding the additive inverse to A. Okay? And that's a useful way to deal with the subtraction of integers, aside from using your calculator. So you see some examples here. Let me see how it says. Okay. So the first one says 17 minus negative 11. So if we follow this rule here, 17, you're going to say plus, because you're going to change to addition following this here. And then the additive inverse of negative 11 is 11. 17 plus 11 is 28. In this second example, you have negative 18. And then you're going to change that to an addition. And the additive inverse of negative 5 is 5, positive 5. And once you change it to an addition, you're going to follow the rule for addition. The two signs are different. So you're going to subtract. So you're going to get 13. 5 from 18 is 13. And since 18 is the larger absolute value, you're going to give the answer the sign that 18 had. This last one here, C, negative 18. This is a subtraction, so you're going to change that to addition. This 5 was positive, so it becomes negative 5. So now you have an addition here where the two signs are the same, negative 18 plus negative 5. So when you add those two together, because the signs are the same, you're going to add them together. That's going to give you 23. And your answer will have the common sign to both of them, which is negative. So that's negative 23. Okay. So when we are subtracting integers, we can change to an addition and change the second number to its additive inverse, and then we follow the rule for addition. Okay, so the examples that I just did here, they are stated right here. This is page 242 of your book, if you have the book. And of course, because you have calculators, you can also use your calculator to do the same thing. All right, but if you don't have a calculator, or you want to do it mentally, then you could follow that principle of adding the additive inverse when you have to subtract. So I want you to look at those three. I give you a couple minutes to do them, and I'm going to call on each of you to tell me what you did for at least one. You could use the calculator or you could use the rule. Okay, So let me start with who now? Let me see. Okay, Miss Nan. Tell me what you did for the A.
Okay, so I said 30 plus, and I turned a -7 to a +7,
Mm-hmm.
and then equals 37.
Okay, very good. Understand. Mhm. That was Miss Nan. Okay, Miss Pratt, what you did for B.
-14 minus the -10, so it's -4. It takes on the sign of the biggest number.
So what you use, the calculator, or you use the rules?
I use the calculator.
Or use the calculator. Okay,
Mhm.
okay. You say you got -4.
Yes, sir.
Okay. All right, Miss La Rochelle, did you do the second one, B?
I did C. B is -14 minus -10, -4.
Tell me what you did with the, how do you do it?
I use a calculator.
Oh, use a calculator. Now, if you use a calculator, you
Do you want me to do it the other way, where you add the 10 to the -4?
okay. So with B, it's going to be -14. And you're going to change, if you're using the additive inverse, you're going to change that to a plus. And then you're going to, the additive inverse of -10 is what?
+10.
+10. So it's just going to be -14 plus 10. Okay. So -14 plus 10, the two of them have different signs. So you're going to subtract and you give the answer the sign that the, with the one with the greater absolute value. So the answer is -4. -4, sorry. -4. Okay. All right. I just wanted some explanation for the answer. I know you could use a calculator, but it's also good to be aware of how it's worked out. Okay, so Ms. Fernanda, what about C?
That's the one, we only had 3. That's what we just did.
Yeah, so C. We didn't do C yet.
Oh,
Mhm.
yeah, that wasn't what we did. Oh,
I asked
-14.
two
I thought
persons
we
to
just
do.
did it.
No, we just did B again.
Oh,
Yeah, I
okay,
wanted.
so -14.
Mhm.
We would take the -14 and we'll add it, and it'll be -5. I mean -10. Sorry, what am I looking at?
Okay. Mhm. So your answer is
-14, -10. That'll be -24.
thank you. Very good. Mhm.
Or am I supposed to make that a positive? No.
-24. Okay.
I have a
-24.
question. Why would it be -24 if we have two like signs?
Ask that question again.
Or we have two like signs.
Yeah. So what would you saying? Because there are two like signs, it should be.
It should be positive, eh?
Okay. So let me go back. Let me go back. Okay. So when it comes to addition, this is the topic we're on right now. Addition. If the integers have the same sign, add their absolute values, the sign of the sum is the same sign of the two numbers. Now, you are telling me the rule for something else. Anybody want to tell me what rule that is? She mentioned when you have two signs the same, the answer will be positive. What operation are we doing for that rule to apply? Anybody remember? There is a time when two negative signs will give you a positive result, but it's not for addition. Nobody remembers? No? Miss La Rochelle, you remember? Miss La Rochelle, are you there?
Can you repeat the question, please?
Yeah, I'm saying to you that for a certain operation with integers, when you have two like signs, the result will be positive. It's not addition. Remember now, we have four operations with numbers: addition, multiplication, division, and subtraction. Nobody remember? Okay, I'll leave that for now because we're gonna come to it in the lesson anyway. But for Miss Pratt, who asked the question, when we are adding, if the two numbers have the same sign, the answer will have the sign that those two numbers have. So if the two of them are positive, the answer will be positive. The two of them are negative, the answer will be negative. That's the rule for addition. But the question you asked has to do with another operation, which we're going to come to a little later on. All right, so when we come to that, we'll discuss that some more. Okay, so we just finished looking at checkpoint 4, so let's move on then to, we came to okay. So the rule now for multiplication of integers. It says here, the result of multiplying two or more numbers is called a product. So when you multiply numbers, the answer that you get is called a product. And they ask you to think of multiplication as repeated addition or subtraction that starts at 0. So we move on then. Now look at the rule for multiplication of integers. The first rule says the product of two integers with different sign is found by multiplying the absolute values. The product is negative. So this example here, you're multiplying a positive 7 by a negative 5. 7 5s are 35. The answer will be negative. Now look at rule 2. I think this is the rule that Miss Pratt was referring to, but that rule applies to multiplication. The product of two integers with the same sign is found by multiplying their absolute values. The product is positive. Ms. Pratt, you see that?
Yeah.
So that only applies when we are multiplying. When we are multiplying two negative numbers, the answer will be positive. If you're multiplying two positive numbers, the answer will be positive. But if you're multiplying a negative and a positive number, the answer is negative. So once the two signs are the same for multiplication, you're going to get a positive result, but that does not apply for addition. If you're adding two negative numbers, the answer will be negative. If you're adding two positive numbers, the answer will be positive. Okay? Number 3 says, the product of 0 and any integer is 0. So anything you multiply by 0, you're going to get 0. Whether the answer is negative or positive, the answer is 0. Number 4 says, if no number is 0, the product of an odd number of negative numbers is found by multiplying their absolute value. The product is negative. So look at this one here. I'm looking at this one here that says negative 2 times negative 3 times negative 5. Why is the answer a negative 30 instead of a positive 30?
Because the numbers are odd.
Okay, because we are multiplying an odd set of numbers. If you are multiplying an even set of numbers, then it would be positive. But because we are multiplying, and if they're all negative, sorry. If you are multiplying an even set of numbers and they're all negative, the answer will be positive. But because we're doing 3 numbers here, negative 2, -3, -5. Because all three of them are negative, your answer will be negative. But if I'd given you -2 times -3 times -5 times -4, you have 1, 2, 3, 4 numbers. The answer would end up being positive because you have an even set of negative numbers to multiply. Okay, so that's number 4. And then this last one, number 5, says if no number is 0, the product of an even number of negative factors is found by multiplying their absolute values. The product is positive. Okay, so if you have an even number of negative factors, then the product is positive. So in this example here, 2 of the numbers are negative. So that's an even number. 2 is even. So -2 times 6. Sorry, -2 times 3 gives you -6. -6 times -5 gives you a positive 30. You have 2 numbers in these factors which are negative. So your answer will be positive. Okay. So right here now, we have Miss Pratt. You probably need to move. Okay.
I go on, Mr. Allen. You already lost me, so at this point, go
Oh,
on.
hold on now. I don't want you. I don't want to lose you. That's Miss Pratt.
Yes.
No, I don't want you to be lost.
Oh.
So I have to go back. Where we are here, where we talk about rules for multiplication of integers. Okay. So the first one, it says if the two numbers have different signs, the answer will be negative. That's the first one. The second one says if the two numbers have the same sign, the answer will be positive, which is right here. Okay, so it's either the two numbers have the same sign or the two numbers have different signs. If they have the same sign, the answer is positive. If they have different signs, the answer is negative. The next thing here is just simply saying to you that if you're multiplying any integer with 0, your answer is going to be 0. Okay. This next one is saying that if you are multiplying a set of negative numbers, if the number of numbers you are multiplying is odd, then your answer will be negative. So in this third one, this fourth one, we have 1, 2, 3 numbers which are negative. So your answer will be negative. Now, if you had 4 numbers which are negative, your answer will be positive. So even set of odd negative numbers, when you multiply them, you get a positive result. Odd set of negative numbers, when you're multiplying them, your answer will be negative. And I
Sorry,
guess
Mr. Allen. You're referring to odd and even. In this case, you're referring to
the amount of numbers you're multiplying.
Okay, all right.
Not the actual numbers, but the amount of numbers you're multiplying. You follow?
Yes, I understand now.
Okay. All right. Okay. So here now we are looking at exponential notation. And when we talk about exponents, basically we're looking at what we refer to as powers. Okay. So this here 2 is the exponent. This here is an exponent. This here is an exponent. This is an exponent here. So I circled all exponents. So this one is telling us -6 to the second power. This one is asking also for -6 to the second power. C is saying -5 raised to the third power. And D is saying -2 raised to the fourth power. So we're going to look at how to approach these, because we are multiplying. In each case, we are looking at negative numbers and we are raising them to a certain power. So we're still doing multiplication here. So the first one is -6. So you'll see it here. Basically, it's saying -6 times -6. That's the first one. I just rewrote it here. So -6 times -6, you're multiplying two negative numbers. And because the signs are the same, the answer is going to end up being a +36. Now in the second one, it looked similar, but there's a difference. In this first one, the -6 is in brackets. Okay? In the second one, the 6 is not in brackets. It's negative of 6 squared. So it's the 6 that you're going to square, and you're going to find the negative of it. So that's how that's written, negative of 6 times 6. So you're not squaring -6, but you're just squaring the 6 itself, and you give the negative of it. Whereas with the first one, you're multiplying -6 times -6. So this is equal then, 6 times 6 is 36, and the negative of that is -36. In this third one, C, you have brackets, -5 to the third. So that is actually saying to you, I want -5 times -5 times -5. So you're multiplying -5 by itself 3 times. So because you have an odd number of 5s here, you have 3 5s, your answer will be negative. Okay? So you say 5 times 5 is 25, 5 times 25 is 125. So your answer then is equal to -125. Because you have 3 5s you're multiplying. Now in this last one, you have -2, you're to the 4th power. So you're going to multiply -2 times -2 times -2 times, oops, okay, times -2. So you're multiplying 2 by itself 4 times. And because that's an even set of times you're multiplying it, 1, 2, 3, 4, that means your answer is going to be positive. And so you say 2 2s 4, 2 4s 8, 2 8, 16. Your answer is a +16. Okay? And so that's the application of the rule for multiplying using integers. I'm going to ask you to try these 4. Give you a couple minutes to work on those 4 using the same rules that we just looked at. So it's 4 of them, so it's 1 for each of you. I'll call on you in a minute. Slide 26.
Okay. Whatever, battery's down.
Okay, Ms. Pratt,
Hi,
okay, tell me what you did for A.
I did -5 times -5 give you a positive 25.
You, okay, thank you. Okay, Miss Nairn, what about B?
For B, I did 5 times 5 equals -25.
Okay, so it really should be like this.
Yeah,
The
that's how I
negative
did it.
comes out. Okay, so that's equal to -25. Thank you. Okay, Miss La Rochelle, what you have for C?
I did negative open bracket 4 times -4 times -4 gives you -64.
Thank you. Okay, and Miss Fernanda?
I did -3
Mhm.
times -3 times -3 times -1.
And what's your answer?
Positive 81, yeah.
81, okay.
Positive 81.
Okay, 81. Thank you. All right. Okay, so that was multiplication of integers. Now the result of dividing an integer by the non-zero another integer which is not 0 is called the quotient. So when you divide two numbers, the answer you get is called the quotient. And we write this quotient as A divided by B or A over B. And so they give an example here. If you have -12, now the rules for division with two integers is same as the rules for multiplication. So if the two numbers have the same sign, the answer is positive. If the two numbers have different signs, the answer is negative. So as you will see in this example, -12 divided by 4, because the numbers have different signs, the answer will be negative. Okay, and so all the rules are right here. Okay, so the first one says the quotient of two integers with different sign is found by dividing their absolute values. The quotient is negative. So the first two examples here refer to that first one. Okay, those have different signs, so the answer is negative. And now the rule 2 says the quotient of two integers with the same sign is found by dividing the absolute values. The quotient is positive. So these next two examples is referring to rule 2. So 27 divided by 9 is 3, and negative 45 divided by negative 3 is 15. So it is the same rule as when we are doing multiplication. Now remember, this rule does not apply for addition. It only applies for multiplication and division. And then number 3 is saying to you that if you divide 0 by any non-zero integer, the result is 0. So if you have 0 as your numerator and you divide by any integer aside from 0, your answer will be 0. And then the fourth rule says that division by 0 is undefined. So you'll find that if you were to try to divide by 0 on your calculator, you'll get an error message because there's no division by 0. You can't divide by 0. Okay, so you try to divide anything by 0, you get error. Can't divide by 0. Well, some calculators actually tell you can't divide by 0, or some just give you the error symbol. Okay, so of course, because we're using calculators, you'll see the technology section on the right-hand side of the slide. Basically, much of this can be done using a calculator. It's good to know the rules because sometimes you make a mistake. You may see that you have 2 negative numbers working with to divide, and you might have not touched the negative as you were entering, and you get the wrong sign for your answer. If you mentally already know that your answer should be positive or your answer should be negative, then that helps, because even though you may be using a calculator, sometimes we can make errors in our entry. So it's always good to have some idea as to what kind of signage your answer should have, or even a rough estimate of what your answer should be as you use the calculator. So you could guess whether your answer is on the right track or not. Okay. Now, another thing we look at in this section is something referred to as order of operations. Okay, so many of you might remember from school days, BODMAS. In this book, they use the term PEDMAS. Okay, and the little mnemonic to help you remember it, please excuse my aunt, dear Sally. P for parentheses or brackets, E for exponents. Then you notice they have multiplication and division together with these brackets. That means that you do it in the order that they appear. So the fact that multiplication is on top doesn't mean that you must do it first. You do them in the order that they appear. So if the multiplication comes first, you do it. If the division comes first, you do it first. So you just do it in the order that they appear. And then you will notice at the bottom now, they have addition and subtraction paired together. So it says you have to do them in the order they appear. So you will see, number 1, perform all operations within grouping symbols. And by grouping symbols, we are referring to parentheses or brackets. Then number 2, deal with all the exponents, that's the powers. Then number 3, it says do all multiplications and divisions in the order which they occur, working from left to right. So if the division comes before the multiplication, you do the division first. But if the multiplication comes first, you do it first. So you're working from left to right, whichever comes first, you do those first as far as multiplication and division goes. So once you finish your brackets, your exponents, your multiplication and division, then the last thing you do is your addition and subtraction, again, from left to right in the order that they occur. So it makes more sense when we try an example. So we have this example here, slide 30. where you are asked to simplify 6 to the second power minus 24 divided by 2 to the second power times 3 plus 1. This dot here in the book that indicates multiplication. So because we are using the P, E, M, D, A, S, okay, do these two first, then these two, then these two. So there are no parentheses in this, no brackets. So the first thing we're gonna do then is the exponents. So this is the question. Exponent 6 squared is 36. This next 2 squared is 4. So basically we have written it over this. The 36 is the 6 squared minus 24 divided by 2 squared is 4 times 3 plus 1. So we have gotten rid of all the exponents. So we finished power, we finished exponents. The next thing is to do multiplication and division. So it says 36 minus 24 divided by 4 times 3 plus 1. So we're going to do the division first because the division came before the multiplication. So 36 and then 24 divided by 4 is 6. So this 6 here is the answer from this division. All right, so 36 minus 6 times 3 plus 1. So we still have another the multiplication to do. So we're going to go to the next line now. We're going to multiply this 6 times 3, 36 minus 18 plus 1. So we are finished with all the multiplication and division. So all we have left to do now is addition and subtraction. And you do it in the order that it appears. So the subtraction came first. So you're going to say 36 minus 18 is 18. And then you bring the 1 down. 18 plus 1 is 19. And so that's how we complete that to make sure we are following the standard of PEDMA, so the correct order of operations. If you change the order, you are likely to get a different answer. So in order to avoid confusion, to make that sure that we are all on the same page, when it comes to calculations, we have an established order of operations. Brackets and parentheses first, exponents next, then multiplication and division in the order they appear, then addition and subtraction in the order that they appear. And so that's the established procedure for multiple operations. All right, so I want you to look at this one, checkpoint 7. Give you a couple minutes to work that, and then we're gonna move on. Okay, do I have any volunteers?
I'll go. Oh, sorry. So,
Okay, the first person was Miss Pratt. So you can go ahead, Miss Pratt.
Okay, so we have to do all the grouping symbols first. So we'll do 49 minus 48 divided into 8 times 5 plus 2.
Okay, you have one mistake here. This here, 4 to the second
Right.
power. 4 to the second power. That's 4 times 4.
Oh, okay. 4 and 4 is 16.
16, okay. Times 5 plus 2. So one thing you said do the grouping symbols first. With this one, we don't have any grouping symbols. The grouping symbols would be your brackets or your parentheses. So what you just did was the exponent. Exponents, yeah, the powers. Okay, so that's the first thing you did, because since we didn't have any brackets or grouping symbols, we do the exponents. All right, so you have done the exponents. So what's the next step?
So now you would need to how they appear. So it'll be, we didn't have any addition, so we would need to do the multiplication
Okay.
and the division,
Okay.
sorry, and multiplication.
Okay. So tell me what's next then. What's you gonna write in the next line?
Okay, so you have 49
Mm-hmm.
minus
Mm-hmm.
so
48 divided by 48 divided by 16 gives you what?
3.
Okay, so we're gonna put times 5 plus 2. Okay, so we did the division. So let's go now to the next thing.
Multiplication.
Okay, it's 49. So 3 times 5 is
15.
okay. Okay, next step.
So 49 minus 15
Mm-hmm.
will give you 34, and then plus 2.
Okay. All right. Thank you, Miss Pratt. Okay. Now, as Miss Pratt was explaining, I just want to remind you, the first thing is grouping symbols. You need to look for that. If you don't see that, the next thing is exponents. That's so step 1, step 2. Step 3 is multiplication or division in the order that they appear. So you notice they put brackets around them in their order. So if the division comes first, you do the division first. The multiplication comes first, you do the multiplication first. Okay, so you don't go looking for the multiplication if the division came before it. In this case, we did have the division before, so that's why we did that first. And then the last thing you do is addition and subtraction in the order that they appear. Okay, so that's the order in which we complete questions like this. Thank you. So now let's look at this other example. So it's basically the same principle we are following, but this time we do have some grouping symbols. Now, we have to be careful when we look at some of the questions, because even though brackets may be there, some of those brackets are not actually grouping symbols. Okay, anybody could tell me which of those brackets have grouping? Miss Nairn? Hold on. Yeah, Miss Nairn, which of those actually is representing a grouping?
It would be the 5 minus 7 squared.
Okay, so the -6 is they just put the -6 in brackets, and that -3 is is just a negative number in brackets. So it's not actually a grouping symbol. That's just a single number, but they wanted to make sure to distinguish it as a -3. So the only grouping there would be the 5 minus 7. So when we tackle this question, so what they have done, they have written it over here. So the first thing they did was to do in the brackets, 5 minus 7 gives you -2. So they've rewritten it without that 5 minus 7, because they worked out the 5 minus 7 to give you -2. Okay. And so once we get our -2 now, we finish with the grouping symbols. The next thing is to deal with the exponents. So this first one is -6 to the second power. -6 times -6 gives you a positive 36. And then this next one is -2 to the second power, which gives you a positive 4. But remember now we have that minus sign outside here. So it's still going to be a minus sign, but this -2 times -2 would be a +4. So this is like actually saying like 36 minus a positive 4. And then you have the -3 there. Of course, that means multiplication. So the next step now is to do the multiplication, because you're going to have 4 times -3. So that's 36 minus 4 times -3 gives you -12. And then 36 minus a -12 gives you 36 plus 12, which is 48. Okay, so that's the final answer for that. Of course, questions like this can be done. If you have a scientific calculator, you could enter the entire thing in your scientific calculator as it is. You put in your brackets and everything, and you should be able to get the same answer that we have here. So you could always try it with your calculator to see if you can derive the answers, because the way you enter it will vary depending on the type of calculator you have. And so you would have to experiment with it and see which approach you could use to get the answer that's displayed. All right, so let's try this one. So this one has the grouping symbol along with exponents and multiplication and subtraction. So go ahead and work on that. I'll give you a couple minutes to do that. We go from there. Okay, Miss Fernanda, tell me what you have done so far. Miss
I'm
Fernanda,
working out the negative, the brackets.
okay, tell me what you started with, what you did first.
So I did the negative 8 square, and I got 64.
Mm-hmm.
Then I took did the bracket with 10 minus 13
Mm-hmm.
square, and I got 9 for that. And then it says multiplied by 2 minus 2, negative 2. So that'll be 64 minus 9 times negative 2. So then after that, I took the 64 and I minus 9 and got 55. That's 55 times negative 2. So my next line would be negative 110. I don't know.
Okay, I kind of, all right. I want you to, you could do multiple steps at a time, but it works out much easier and you're more accurate when you follow the brackets
Mm-hmm.
first, then parentheses, sorry, not, then exponents, then multiply and divide, then add and subtract. So the brackets portion is right here, the 10 minus 13. So you can write back everything and just work out that brackets portion. So you're gonna have negative 8 to the second power. Now, when you say 10, what is 10 minus 13?
Negative 3.
Negative 3.
Negative. Okay. So Miss Fernanda, you said negative 3? Okay, so you're gonna put then negative 3 to the second power and then times negative 2. So I prefer if you do it in that order, it reduces the chance of errors because you're dealing with the brackets. So your first thing is deal with the brackets. So you deal with that bracket, 10 minus 13 is negative 3. And you bring everything else down, just work out what's in the bracket. So there are no more brackets to deal with. Or I should say brackets, I should say grouping symbols. No more grouping symbols because these other brackets are just indicating negative numbers. The next thing now is your exponents. So your exponents, you have two exponents here. You have negative 8 to the second, and you have negative 3 to the second. Now you said negative 8 to the second gives you what?
64.
Okay, that's 64. Okay. Minus, and what is negative 3 to the second?
9.
9, and then times negative 2. Okay. So you finished with the exponents. The next thing is the multiplication and division. Now, we don't have any division here, but we have a multiplication. So this multiplication is 9 times negative 2. So 64 minus, what is 9 times negative 2?
Negative 18.
That's negative 18. So we finished with the multiplication and division. Now we're going to do the addition and subtraction. We don't have no addition, but we have a subtraction. Subtraction says 64 minus 18.
So it's 82. Okay.
So the answer is equal to 82. Right.
So I got 82.
Mm-hmm.
Yeah.
All right. But the key thing is to just follow that order, do the brackets, finish that. Just make sure you simplify everything in the brackets, then deal with the exponents, then deal with the multiplication division, then deal with addition and subtraction. I mean, you can do multiple steps, because I could have done it like this. I can write it over and show you how you could reduce your working, but sometimes that causes a little problem with your steps. So I'm going to write it over. 10 minus 13 to the second times minus 2. So if you wanted to, you could go straight ahead and say that is 64. And then you could say minus, what's this? Negative 3 squared times negative 2. So you could do the multiple steps right there. Then you could go back and deal with this exponents part and say 64 minus 9 times negative 2. Then 64 multiply, that would be minus negative 18. And it's still going to end up giving you equal to 82. So you could have, the only difference is you could have just done this at the same time when you were doing simplifying the bracket. So it would still give you the same, if you're careful, it will still give you the same answer. But I find it's helpful and it reduces your chance of mistake if you just deal with one step at a time. Deal with the brackets, then the exponents, then the multiplication division, then the addition and subtraction. But after you do several of them, you will see where you can kind of reduce some of the working if you do certain things together. But that's when your confidence level build up after you'd have done several of them. All right, but it's safer to do one step at a time to reduce errors. Okay. All right, so basically then this ends our look at section 5.2. So 5.2 was dealing with integers. Integers, extend the number line. What is included in integers that's not in the set of natural numbers, Miss Nairn? How do integers and natural numbers differ?
Integers have negative numbers and 0.
Okay, along with positive numbers.
Yeah.
Whereas the natural numbers just have 1 onwards, doesn't have zeros, it doesn't have negative numbers. So that's your integers. Integers, you can multiply them, you can add them, you could subtract them, you could divide them, you could use order of operations with them. Be careful, because that's a mistake that people keep making when it comes to multiplying and adding integers. Many persons confuse the rules for multiplication with addition. When you're adding integers, if the two numbers have the same sign, the answer will have the sign that those two numbers have. So if the two numbers you're adding are positive, the answer will be positive. 5 plus 8 is 13. The two of them have the same sign. They're both positive. So the answer will be positive. That's 5 plus 8. But if I say negative 5 plus negative 8, the two of them are negative. So when you add negative 5 plus negative 8, you're going to get negative 13. They are two negative numbers that you're adding together. They will take the sign that they both have. When it comes to multiplication, that is not the case. When you're multiplying numbers, if the two numbers have the same sign, the answer will be positive. So if you're multiplying negative 5 times negative 8, the answer will be a positive 40. 5 times 8 will also be a positive 40. So if the two numbers have the same sign when you're multiplying, Whether the two are negative or the two are positive, the answer will be positive. So do not confuse the addition property for integers with the multiplication and division property. Just be mindful of that. All right, so in section 5.3, which begins on page 250, you'll get some homework later on to do for section 5.2, but 5.3 begins on page 250, and that deals with another set of numbers now. This set of numbers we refer to as rational. Now, what makes rational different from all the other numbers that we look at? The rational numbers will include fractions. So the numbers we were looking at before did not include fractions. And so the general rule for this definition of a rational number, you will see here, it says the set of rational numbers is a set of all numbers which can be expressed in the form A over B. So any number that could be expressed in that form A over B, where A and B are integers and A is not equal to 0, is a rational number. The integer A is called the numerator and the integer B is called the denominator. So already you see some terms that use with fractions involved here. So fractions would be included in the set of rational numbers. Okay, and they give you some examples. A quarter, negative a half. So you could have negative numbers too in the rational numbers, negative fractions. 3/4, 5. Now, how could you express 5 in the form A over B? Anybody? How could we express? Say that again.
1 over 5? Or 5?
It's the
5
other
over
way
1?
around. 5 over 1.
5 over 1.
Okay,
Yeah.
so 5 over 1 is the same as 5. Okay, so any number that you could express as A over B that gives the same value as the number is a rational number. So 5 over 1, because 5 is a rational because you could express it as 5 over 1. 0 is a rational because you could put it 0 over 1. Okay, so anything that could be written in that fraction form is a rational number. Okay, now they talk about reducing rational numbers. Okay, so we can reduce rational numbers. It says if AB is a rational number and C is any number other than 0, okay, so you could simplify it. A times C over B times C can be simplified to A over B. Because C is common, you could cancel out the C and reduce it to A over B. And it says here that the rational numbers A and B, A over B, and AC over BC are called equivalent fractions. And to reduce them, we divide the numerator and the denominator by the greatest common divisor. That's how we reduce it. So I don't want to go back. I think, yeah, we did go through the process of finding common divisors. So we're not looking at that now, but we are just looking at this one here with, where you're asked to reduce 130 over 455 to lowest terms. Now you can go through it step by step, but they seem like they're encouraging you to find the lowest, the greatest common divisor. So in this case, it is 65. They work it out to 65. So if you divide 130 by 65, you get 2. And you could divide 455 by 65, and I think you get 7. So that works out to 2/7. Now, if you want to, instead of going through all of that, you could look at 130 over 455. And right away, you could see that 5 could divide because this ends with 0 and that ends with 5. So you could do another method. You could say 5 into this is 5 into that is 2 into 13, remainder 3. 5 into 30 is 6. Then 5 into 45 is 9. That's 1. Then you could look now, say, what else could I divide this by? You could divide by 13. 13 into 26 is 2. And 13 into 91 is 7. That's equal to 2/7. So you could cancel out to reduce, or you could find the greatest common divisor and divide by that. So just explain some of the working here. And so the answer was 2/7. Okay, so let's look at this example here. All right, so this one says 72 over 90. We want to reduce that to lowest terms. How could we start this reduction? I don't want to go through the LCM method. Let's just reduce it by canceling. What could we use to start
3.
canceling?
3.
3? Okay. 3 into that is, that's 2, 24. 3 into this is 30. Anything else we could use? We could use 3 again.
Yes.
Yeah, okay. 3 into this is what? 3 8s, 24. And 3 into that is 10.
Mhm.
What else?
2.
2. Okay.
So
2 into that is 4. And 2 into this is 5. Anything else?
no.
That's it. All right. So in lower terms, then that's equal to 4/5. All right. So even though in your book, they encourage you to use the LCM method, sometimes it takes a little long to work through all of that. If you could find numbers that could divide the numerator and the denominator, you could just go through the canceling process, and it tends to be a little quicker. In fact, some calculators could even do that for you. If you have one of those scientific calculators, you could put the 72, then you press your fraction key. I'm not sure what the fraction key look like on the different calculators. Some look like this, some look like A, B/C. And if you put 72 and then you press your fraction key and then you press 90, it will reduce it to the lowest terms for you. So, but if you just have a regular calculator, then it wouldn't be able to do that. But most of the scientific calculators could do that. Remember now, for your exam, you cannot use your cell phone. So you have to get a calculator, a scientific calculator for that. And it's best not to wait until the exam time to get that calculator, because some of the functions you wouldn't understand until you use it. So if you can get one now and practice using it so that you're familiar with it before your exam. Okay, so that's reducing. Okay, mixed numbers and improper fraction. So a mixed number consists of an integer and a rational number. So this here is an example of a mixed number. You have this integer and you have this rational. So it's a whole number and a fraction. And then of course, this here would be the improper fraction. An improper fraction is a rational number whose numerator is greater than its denominator. So you have a number at the top which is greater than the number at the bottom. You have what is called an improper fraction. I think you should be familiar with that. I don't need to spend too much time there. Okay, you should be able to also do the conversion So if you want to change the 3 4/5 to an improper, 3 times 5 is 15 plus 4. So what they did, they put the numerator, sorry, the whole number and the denominator, and then you add the numerator. 3 times 5 plus 4. 3 5 is 15 plus 4 is 19, and you put it over the denominator. And so that's how you convert from mixed number to improper fraction. Somebody want to tell me what the answer is? No, let me call a name. Fabian, La Rochelle, could you tell me how you're going to change this to an improper fraction? 2 5/8?
2 times 8 is 16.
2 times 8.
2 times 8 is 16. Then you're gonna add 5 to 16, which will be 21 over 8.
Okay, so that's over 8. All right, so that's 21 over 8. So you multiply the numerator and the I don't know why I keep saying that. You multiply the whole number and the denominator, and then you add the numerator to it, and then you put your answer over the denominator. So in this case, it's 21 over 8. Okay, thank you. And so we're now doing the reverse, doing the improper fraction back to a mixed number. So you're going to divide the denominator into the numerator, and then you're going to put the quotient and the remainder over the denominator to write it as a mixed number. So you have this example, 42 over 5. So you say 5 into 42 goes 8 times, and the remainder is 2. So your answer then would be 8 and 2 over 5. Okay? So this is a step that you should be familiar with. So let's just quickly look at this one here. Oh, this is an easy one. Let me see. I just asked Miss Rochelle. Let me see. Miss Nairn. What's the answer for that one?
1 and 2 over 3.
Yes. Okay. So 3 into 5 is 1. Remainder is 2. So the answer is 1 and 2 over 3. All right. Now, here it says any rational number can be expressed as a decimal by dividing the denominator into the numerator. So we have some examples here. Express each rational number as a decimal. So we can rewrite this in decimal form. And with your calculator, you can easily work that out by just saying 8 divided into 5. And in the second one, 7 divided by 11. All right, so you're just going to divide the numerator by the denominator. So in the first one, if you use your calculator, you will see that you will get 0.625. Or if you want to do the long division, you set it up just like what you see here. But you don't have to go through that process if you have a calculator. But you will notice that in this first one, it stopped after 3 places. So this is what we call a terminating decimal. It terminates, it stops, it ends. Now, in the second one, when you divide 11 into 7, it does not terminate. It's called a repeating decimal. In this case, it's repeating. You have some that repeats and some that don't repeat. But this one is repeating. And you notice they put a bar over the 63 because that indicates that the 63 repeats. So you could have just written 0.63 with the bar, but they wrote it after putting another 2 places. That all that means is that it's going to be 0.6363636363 and on and on and on. It repeats infinitely. So that's a repeating decimal. Okay. So sometimes when you convert, it terminates. And sometimes when you convert, it repeats. oftentimes when you're asked to solve problems involving these type of fractions, they might tell you to run it off to a certain number of places. They may say run it to 2 decimal place, 3 decimal place, 1 significant figure, 2 significant figure. So you just have to make sure to read and see what the question asks you to do, because we don't necessarily need to list all the places for every situation. Okay, so that is how we convert. So let's look at these two. I'll give you a minute to do those two, and I'm going to call on two persons to tell me what they get. I'd suggest just use the calculator and work it out. Okay, Ms. Pratt, what you have for the first one?
I see 2.6 and the repeat.
Could you repeat that? I didn't hear you.
3 over 8. 3 over 8.
Yeah, I want to change that to a decimal.
So would it be 2.6 and the repeat symbol over the 6?
Oh, what you did? Tell me how you got that.
I divided 8 into 3.
No, you put the number on top first.
Okay.
So
So it'll be 3.75.
Okay, do that again. 3 divide by 8. 3 divided by 8.
0.375.
Okay, 0.375. And listen, you see, anytime the number on the top is smaller than the number at the bottom, your answer will always be 0 point something. Why? Anybody want to say why? Why is it that if the number on top is smaller than the number at the bottom, your answer will always be 0 point some value? What does 0 point indicate about the number, the size of the number?
It isn't big enough to go into that number, so.
So the answer is going to be less than what?
0, less than 1?
Less than 1. So anytime the number at the top is smaller than the number at the bottom, your answer is always going to be less than 1. So it means that your number will be 0 point some value. So if you see you have a fraction 3 over 8, and you divide and you see you get something greater than 1, if you get 5 point something, 1 point something, you know you did something wrong. It should always be 0 point something if the number on top is smaller than the number at the bottom. Okay, so that answer is 0.6. 325, we said, right?
375, 0.375.
375. Okay, 0.375. Now, is that a terminating or a recurring decimal?
Terminating.
Terminating, that means it ends. Okay, thank you. Ms. Fernanda, what you got for B?
I got 0.455. I rounded it off because it's a repeating decimal.
So if I wanted to shorten that with that bar over it, how would I write that?
0.455.
So just when you enter, give me all of what you got on the calculator. Let me hear.
All right, okay. I got 0.454545.
Okay, so what is repeating then? Tell me what is repeating.
The 4 and the 5.
Okay.
45,
so,
45.
All right. So the short way to reduce that is to just do this. Once you put that bar over the 45, it means that it is repeating. Okay. So you can just put it at 0.45 with that repeat. Now, if the question asks you to give your answer to 3 decimal places or 4 decimal places, then you could write it out and then round it off. But in the case like this, where we didn't actually tell you how to run it off, since you see the pattern of repeat, you could just put the bar over the numbers that repeat. So to indicate that that is a repeating decimal. Okay, so this one is repeating 0.45. Okay, Now, we are looking at the reverse. So we just did writing the fraction, rational number, as a decimal. Now, if you have the decimal and you want to write it as a fraction, what do you do? So what do you do requires you to just do a little bit of review of our decimal place system. So you see the table on the right. When we deal with decimals, that point separates the whole number from the decimal. The first place after the point is tenth, second is hundredth, third is thousand, then 10,000, then 100,000, and it goes on and on. Then, of course, to the left of the point, you have ones, tens, hundreds, thousands, and so on. So if you have this number, for example, 0.7, how many places after the point is in 0.7? How many digits after the point?
1.
One digit after the point. So that first digit after the point is the 10th place. So you could write this 0.7 then as 0.7 equals 7 over 10, because that 7 is in the 10th place. And so you follow the same principle with the second one, which is 0.49. You have two numbers after the point, 1, 2. So the second place after the point is the 100th place. So 0.49 then would be equal to 49 over 100. Okay, this third one, how many numbers we have after the point?
3.
3. So how would we write this as a fraction?
$48
40 over 1,000.
48 over 1,000. Now, in some cases, we can simplify. Okay, so we're going to look at that on the next slide. So the first one was 0.7, which is 7 over 10, because 7 is in the 10th place. The second one is 49 over 100, because 9 is in the 100th place. In the third case, it became 48 over 1,000, because the 8 was in the 1,000th place. 48 over 1,000, though, can be reduced because you could divide by, well, you could divide by 2, then 4, or you could divide by 2, then 2, then 2, but they use the highest common divisor, which in this case is 8. So if you divide by 8, you get 6 over 125. So in lowest terms, it's equal to 6 over 125. But if you wanted to, you could start with a smaller number like 2 and then keep dividing until you can't divide anymore. You'd still get 6 over 125 as your final answer. Okay. All right. So I want you to try these 3. Change them into a quotient of integers, which really means change them into a fraction form. And if it can be reduced, reduce the lowest terms. There's at least one of them can be reduced, so reduce the lowest terms. Okay, Ms. La Rochelle, What you got for A? Mr. Rochelle, are you there? Ms. Fernanda, what you got for A?
I go at 9/10.
Thank you. Ms. Nan, what you got for B?
I got 86 over 100, and then I reduce it to 43 over 50.
Okay, thank you. Ms. Pratt, what you got for C?
53 over 1,000.
Okay, thank you very much. All right. Okay. Okay, now, page 255. I put this, I highlighted this in yellow because I was wondering if I should have done this topic because it's not very common, but it's useful to know from time to time because what we were doing just now, we were looking at decimals that did not repeat. We're looking at terminating decimals to change into a fraction. But when you have repeating decimals, how do you change those into a fraction form? So in your book on page 255, they gave a method that you could use using a little bit of algebra, where you can change a repeating decimal into a quotient of integers, where you have a numerator and a denominator, which is basically fraction form. So let's look at what they have done. So what they have here, they have an example. It says express 0.6. You see the bar over the 6? That means that that 6 repeats. And okay, so solution for that is let n equal the repeated decimal. So they give n equals 0.6 or 0. And they give a number of digits in the repeat. So that's the first step. So you choose a variable to represent the repeating decimal. Step 2, it says if there is one repeating digit, multiply both sides of the equation by 10. So we only have one repeating, which is 6. So you start off with n equals 0.6666. So if you multiply both sides by 10, 10 times n gives you 10n, 10 times 0. That gives you 6.666. Okay, so we're going to go to the next stage now. Step 3 says you're going to subtract the equation in step 1 from the equation in step 2. So when you did the multiplication, this is what you got. 10n equals 6.66 and so on. And when you started off by saying n is equal to 0. And if you subtract 10n minus n gives you 9n, and 6.6 and so on, subtract 0 gives you 6. So it's saying that 9n is equal to 6. Okay. And they have a little note on the side here, just reminding you that the letter by itself is like 1n. So if you have 10n minus 1n, you get 9n as your result. So now they say divide both sides of the equation in step 3 by the number in front of n. So we want to solve for the equation. So this is where we're going to solve for the equation. So if 9n is equal to 6, then n would be equal to 6 over 9. Okay, and they show the working here. Because if 9n is 6, we're going to divide both sides by 9 to get n. N is equal to 6 over 9, and that 6 over 9 could be reduced to 2/3. And so 2/3 is the result of changing 0.666 repeat into a fraction. And if you check on your calculator, you could divide 2 by 3, and you will get 0.666 repeat. Okay, so that's the step that they have explained here. So if you have the book, it's on page 255. If you don't have the book, I'll be sending you the slides so you'll see the steps. Now, I did this for if you have one, where is it there? One repeating digit. Now the book goes on to look at 2 repeating digits and so on. But the only thing you're going to do if you have 2 repeating digits, you're going to multiply by 100 if it was 2 repeating digits. So if you have 2 repeating, you multiply by 100. So what do you think is going to happen if you have 3 repeating?
Multiply by 1,000.
Multiply by 1,000 and so on. Okay, and you use the same steps, just you would increase the number that you're multiplying by 10-fold. Okay, so we have 2 examples here. So let's see if we could start off with this first one. Anybody want to tell me what's the first step based on what we just looked at? Let's go back over that. So it's 0.2, it's repeat. So that's really like 0.22222, that. So based on what we just looked at for the steps, tell me what's the first thing you're going to do? Miss La Rochelle, are you back with us?
I'm back.
Okay. Yeah. Can you tell me the first step for this? We starting with 0.2 repeat. What's the first step? Miss La Rochelle?
Can you go back to the previous screen?
Mm-hmm.
So you're gonna multiply it by,
Look at step 1. What step 1 says?
let n equal the repeating decimal.
Okay. So we don't have to use n, but let's say we're using n. Let n equal, and what's the repeating decimal?
0.2222.
Okay, 0.2222 ... Okay. So how many digits are repeating? Miss La Rochelle, do we have 1 digit repeating, 2 digits repeating, 3 digits repeating? How many digits are repeating?
1 digit.
1 digit. So what are we going to multiply by?
10.
10. So if you multiply by 10 times 10, so you're going to get 10. Okay. I didn't want to do that like that. So you're going to multiply by 10. So you're going to end up with 10n equals, when you multiply 0.2222 by 10, what do you get?
2.222.
Okay, 2.2222. So now, so we first step is to let n be that. Second step, because we only repeating 1, we're going to multiply by 10. So now this third step, let's go back and see what the third step is. What's the third step?
Subtract it.
Okay, so we're gonna do the subtraction now. So we're gonna put 10n equals 2.2222, so on. And then n equals 0.2222, so on. We're going to do a subtraction. So when we subtract now, Ms. LaRochelle, what do we get?
2.
10n minus n gives you what?
N.
No, 10n, take away 1n.
10.
No, 10n, take away 10n minus n equal to what?
9.
9n. And that's equal to 2.2222 minus 0.222 gives you
2.
2. All right, so 9n is equal to 2. So n would be now equal to what? If 9n is equal to 2, what is n equal to? Anybody else want to finish that? Ms. Pratt, what is
-7. Right there, a 9.
9 times n is equal to 2? So what is n?
2.
2/9.
2/9. You're going to divide by 9. That's 9 times n equals 2. So if you want to find what n is, n will be equal to 2 divided by 9. The opposite of multiplication is divide. Now, if it had said 9 plus n equal 2, then you would say n equals 2 minus 9, because you're going to move the 9 over. But in this case, it was a multiplication, so the opposite would be to divide. So n is, and you could check your answer. Divide 2 by 9 on your calculator and see what you get. What is 2 divided by 9?
2, 2, 2, 2, 2, 2.
0.222.
0.
Okay, so you could always check your answer in these with these questions. All right, look at the next one. What different will we have to do for checkpoint 7 that we didn't do for checkpoint 6?
Use 100.
Okay, we're going to use 100. So we're going to start off by saying let n equals, how are we going to expand this one now? 0. What?
7979.
Okay, 797979. We could do that a couple times. All right. So the next step then would be to multiply by, you say,
100.
100. So you're going to say then 100 times n gives you
100n.
100n. And then 100 times 0.797979 gives you
79.7979.
797979. Okay. What's the next step?
-1.
Okay, so you're going to subtract. You're going to say 100n equals 79.797979 minus the n equals 0.797979. So when you subtract here, you're going to get
99.
99 n
N.
equals
79.
79. So n then would be equal to
79 over 99.
Okay. Try dividing 79 by 99 and see what you get. See if you get back 0.797979.
Yeah, I got it.
Yeah. Okay. So that's that. Okay. All right. So moving on then. Okay. So multiplying rational numbers. If you remember the multiply fractions, that's basically what we are doing here. The product of two rational numbers is the product of their numerators divided by the product of their denominator. All right. So I have a few examples. The first one is A, says 3/8 times 5/11. Two fractions. If you have to multiply two fractions, you multiply the numerator, you multiply the denominator. Sometimes you can simplify it. But in this first one, 3 5s are 15, 8 times 11 is 88. In the second one, it's a negative 2 over 3 times a negative 9 over 4. So it's two fractions, but they are negative. And you notice they put the negative sign on the numerator when they expand it. So negative 2 times negative 9 over 3 times 4. Negative times negative gives you a positive 18. 3 times 4 is 12. And that 18 over 12 could be simplified to 3 over 2 or 1.5. Now you see with C, you have two mixed numbers, 3 2/3 times 1 1/4. You will notice that what they did first was to change the mixed number into an improper fraction. So it becomes 11 over 3 times 5 over 4. 11 over 3 times 5 over 4. When you multiply that out, you get 11 times 5, which is 55. 3 times 4, which is 12. So 55 over 12 reduces to 4 7/12 when you change that into a mixed number. So when you're multiplying rational numbers, if you remember how to do fractions, basically that's the same rules. You're multiplying the numerators, you multiply the denominators, and then you're reducing to lowest terms where you can. So I'm going to ask you to look at these here. Give you a couple of minutes, and then I'll call on you to tell me what you get. Okay, this is Okay. Let me see now. Ms. Pratt, what you got for the first one?
Um, 12/33. And then
Just a sec. Tell me what you did before you
oh,
do that.
sorry, 4 times 3. Oh,
4
okay.
times.
That's 2/8. Sorry,
Yeah, that's cool.
I have on my glasses.
All right.
So that'll be 4 times 2, which will be 8.
Okay.
And then 11 times 3,
Which is
8/33.
33. Thank you very much. All right. Okay, that was Miss Pratt. Miss Nairn, what about number B, part B? What you got?
Okay, so I did 3 multiplied by 14 over 7 multiplied by 4.
Now, that 14, is it a negative 14 or positive 14?
The negative,
Negative 14, okay.
and then
And
I got 21. Sorry, I got 42 over 28.
42 over 28, yes.
And then I reduced it to 21 over 14.
Okay, 21 over 14.
And then I got 1 and 7 over 14.
Okay, can 7 go into 14?
Yes.
So you could still reduce it further then.
So then that will be 1 and 1 over 2.
Right, 1.5. Okay, thank you. All right, Miss Fernanda, what you got for C?
Okay, for C, I got 17 over 5 times 3 over 2. And then, so like I got 51 over 10. And then I broke it, I made it a mixed number. It's 5 and 1/10.
Okay, thank you very much. Okay. All right. Thank you. That was good. So let's go on then. All right. So now that was the multiplication. Now the division is it says here the quotient of 2. And by the way, remember quotient means the answer when you divide. So anytime you see that word, you know you're talking about division. So the quotient of 2 rational numbers is the product of the first number and the reciprocal of the second number. Anybody remember what reciprocal mean again? What is reciprocal? I don't see nobody. Muted, so unmuted. No, nobody remember. If you look at this here, look what happened, what they did. They start off with A over B, divide by C over D. Now, what did they do here? You see the division change to what?
A multiplication and then reverse the numerator and denominator.
Then you notice that this second one here, instead of being C over D, it becomes D over C. So you invert it. The first one didn't change. So A over B, still A over B on this side. So when we talk about reciprocal, what we're basically doing, we invert the fraction. We put the numerator on top. Sorry, we put the denominator on top and the numerator at the bottom. So anytime you have to divide 2 fractions, you can rewrite it over as a multiplication with the reciprocal of the second fraction. So in these examples at the bottom, the first one says 4/5 divided by 1/10. So you see 4/5 divided by 1/10 becomes 4/5 times 10 over 1. Okay, so we change the multiplication and we invert the second fraction. So 4 times 10 is 5 times 1, then 4 times 40, 5 ones 5, 5 into that goes 8. So that's the answer for that first one. The second one, you have 3 over 5 divided by 7 over 11. So you're going to do the inversion again and change the multiplication. So it's 3 over 5 times 11 over 7. And since the first one is negative, it's going to be negative 3 times 11 over 5 times 7. Negative 3 times 11 is negative 33. 5 sevens are 35. So we can't reduce it. So the answer is negative 33 over 35. And then the last one, you have 2 mixed numbers. So you're going to have to change them to improper fraction first. Once you finish doing your improper fraction, then you're going to do the inversion. So you're going to change the multiplication and then multiply by 2 over 3. So you do your multiplication, cancel out. The final answer there is 3 and 1, 6. Okay, so the division requires you to follow the rules of multiplication after you invert the second fraction or find its reciprocal. Okay, so let's look at these 3. Okay, Miss La Rochelle, what you did for the first one? Oh, what you doing so far?
I did 9 over 11 times 4 over 5.
Mm-hmm. Okay. And then from there,
9 times 4 over 11 times 5.
mm-hmm.
Then I got 36 over 55.
Okay, thank you. Okay. Let me see now, Miss Nairn, the next one.
Okay, so I did negative 8 over 15 multiplied by 5 over 2
Mm-hmm.
equals 40 over 30. I reduce
What about the negative?
negative 40.
Okay. Mm-hmm.
And then I reduce it to negative 4 over 3.
Mm-hmm.
And then I guess it'd be negative 1 and 1 over 3.
Mm-hmm. Thank you. Okay. That was Miss Nairn. That was Miss Nairn? Miss Nairn, that was
Yes.
you. Okay, all right. So Miss Pratt then. Miss Pratt for the next one.
I didn't get to that one yet.
Well, we could start it now. Let's start it together. Tell them what to do first. Miss Pratt?
I'm looking over my examples.
Oh, okay. Miss Fernanda, you got to that one yet?
I was just trying it out.
Okay.
Okay, so would it be? So we convert that mixed number into an improper fraction.
Okay.
So that'll be 27 over 8.
27
And then
over
we'll
8.
multiply it by the,
No, before you multiply, you have to do the
And
two
then-
conversions first. So when you
yeah,
convert that,
so I'm converting that other one to that.
so what do you get when you
So
convert
it'll
the
be
other one?
9 over 4.
9 over 4. Okay. So before you change this, just do the conversions first. So that's 3 is 24, 27 over 8 divided by 9 over 4. Now you can convert. So it's going to be 27 over 8
And
times.
then, so
I didn't hear
4
you.
over 9.
4 over 9. Okay.
4 over 9.
Yeah.
4
It's breaking up.
over 72.
Okay. What was on top, you said?
Can you hear me? 108.
Oh, 108. Okay. Over 72, you said. Okay.
72.
Okay.
And then so now we have to I got 1.5 because 72 goes into that one time. And then I broke that. Let me tell you what I got before I broke it. Oh. So that'll be 72. And on using 9.
Okay, so 9 into 108 is, I didn't get that.
12.
Over 9
Can you hear
into,
me?
yeah, you said 9 into 72 is
12. And then so the 12 over 8.
12 over 8. Okay, so 9 into 108 is 12, 9 into that. Okay. And so when you break down the 12 over 8,
Yeah, and then I broke it
becomes
down again.
1 over 2, 1.5. Okay, that's correct.
Yeah. Yeah.
Okay, thank you. Miss
You're
Pat,
welcome.
you were you following?
I followed you all on the screen, but I didn't get it. I a little lost.
Okay, so I'm gonna go back over it. So 3 and 3/8. 3/8 are 24, plus 3 is 27. So we have to convert that to a improper fraction first. And then 2 4s 8 and 1 9 over 4. Okay, so you convert the two of them into improper fraction. So that 3 and 3 has become 27 over 8, and the 2 and a quarter becomes 9 over 4. And we keep the division for now, because all we were doing is converting them into improper fraction. Now, once we finish convert the improper fraction, now we can go ahead and do the reciprocal of the second fraction. So we're going to change this division to multiplication, and we're going to invert this one. So it's going to be 27 over 8 times 4 over 9. And once we do that, now you may, when you multiply the 27 times 4, you get 108. 8 times 9 gives you 72. And you reduce the 108 over 72 to lowest terms, and you get 1.5. Now, what she did, she said, what she used here? She used 9. 9 into 108 goes 12 times, and 9 into 72 is 8. And you could have used another number if you wanted to. You could have gone, say, 4. 4 into 12 is 3, and 4 into 8 is 2. So that's equal to 3 over 2, which reduces to 1.5. Okay.
I have a
So,
question.
yes, go ahead.
What I did was I put it into its lowest term before multiplying.
Yeah, you
So
could do that too, because this 27 over 8, for example, times 4 over 9, you could have said 4 into 4, 1, and 4 into 8 is 2. And then you could say 9 into 9, 1, and 9 into that is 3.
Okay.
Three ones are 3, 2 ones are 2, and that becomes 1.5.
Okay
Yeah.
then.
So you could do it that way. So if you see where you could cancel before you do the multiplication, you could do that. And then that would reduce the amount of working you have to do in terms of breaking down your final answer if you simplify it before. Okay. So that's that. So even this one here that we did, I could go here and bring negative 8 over 15 times 5 over 2. 5 going to 5, 1. 5 and 15 is 3. 22, 1. 2 into 4, that's 8 is negative 4. So we could have said 4 times that gives you negative 4. 3 ones, 3. Okay, and then so equals negative 1 and 1 over 3. So if you can cancel before, you could do that. And that reduces the amount of working in the end. Okay, so that's division. So multiplication and division of rational numbers is basically the same process we do for multiplication and division of fractions. It's basically the same process. But now we are going to look at addition and subtraction. The sum or difference of two rational numbers with identical denominators is the sum or difference of their numerators over the common denominator. Okay, so now I think it's better for us to look at an example. So anytime you're doing fractions, when it comes to adding and subtracting, only when it comes to adding and subtracting, not multiplication and division. When we multiply and dividing, we're not so much concerned about the denominators because we're going to just multiply the denominators. But when it comes to adding and subtracting, we must have the same denominator in order to add or subtract. If we don't have the same denominator, then we have to convert the fractions so that they both have the same denominator. Now, in these three examples that you are given here, for example, 10, all of these fractions have the same denominator. So the first one says 3/7 over 2/7. Once they have the same denominator, all we do is add the numerator. So 3 plus 2 is 5. So the answer in this case is 5 over 7. In the second one, you're subtracting. For same process again, whether you're adding or subtracting, the denominators must be the same. So 11 over 12 minus 5 over 12. When you do that, you end up with 6 over 12. And 6 over 12 reduces to a half. If you are doing mixed numbers, now some let me see what they did here. Okay, in some cases, they recommend that you do the whole numbers separate from the fractions. But in this book, what they did is to convert them. So 5 1/4 becomes negative 21 over 4. And then minus 2 1/3 becomes negative 11 over 4. So they convert them into improper fraction. And because they have the same denominator, all we do is deal with the numerators, add or subtract as the case may be. So you have negative 21 plus 11. Okay, gives you a negative 10 over 4, which works out to negative 2 1/2. Okay, So once they have the same denominator, we don't have to do any conversion. We simply just add the numerators. So I'm not going to ask you all to do this. I'm going to just call and person tell me what to do. Miss Pratt, what's the answer for A?
8/12 when you reduce.
Okay, so 8/12, which could be reduced to 4 into that is 2, 4 into that is 3. So that becomes 2/3. Thank you. Miss Nairn, what's the answer for B?
So that'll be 6/4.
6/4.
And that'll be 1 and 2/4.
Okay, so 1 and 2/4 is the same as 1 and what? 2/4 could be
1 and
reduced
1/2.
Okay, 1.5. Thank you. Okay, Miss La Rochelle, tell me what we need to do in C.
Why you give me that one?
Why not? Tell me what to do.
We can do 3 into 8 is, we can turn them into an improper fraction. So 3.
Okay. 3 8s are 24 plus 3 is
27/8 over 8.
27/8. And by the way, that's negative 27. Okay. Minus. And then we're going to
In the bracket, that would be 9/8.
9/8. And by the way, that's negative 9 because we had a negative fraction there. So the denominators are the same. So we just need to worry about the numerator. So that's going to be negative 27 minus 9.
So that'll be negative 27 plus 9.
So negative 27 plus 9 over 8.
So that'll be negative 18/8.
Negative 18/8. So that reduces to
So negative 3 5/8.
negative who?
Sorry, negative 2. 2/8. So negative 2 1/4.
Okay, so that's equal to negative 2 1/4. Thank you. Yeah, very good. Yeah, okay. So that's number. Okay, so that's it for that. Okay, so let me see now. So now we were dealing with like denominators. Now what happens when the denominators are not alike?
You have to find the LC, the lowest common denominator.
Right, so that's what we're going to look at now. So we have this one where you're asked to add these two, 3/4 plus 1/6. So you find the lowest common denominator. In this case, for this example, the lowest common denominator is 12. Okay. Of course, you know, you should be able to use your calculators too to do this. If you have a scientific calculator, you can use the fraction key and do your additions if you have the scientific calculator. But if you don't have the scientific calculator and you want to do it manually, you have to find a common denominator. So in this case, the common denominator is 12. Okay, so you're going to say equal something over 12 plus something else over 12. Now, how did they get this 9 and this 2 on top? How did they get the 9 and the 2 on top there? Why do we have to change the numerator? Anybody? You notice they have a 9 here and 2 there. Why?
The 3 times 3 is 9.
Okay, where you got that 3? Why are you multiplying by 3? 3 times 3 is 9. You are correct, but why are you multiplying by 3? That was Miss Pratt.
Because the 3, yeah.
Mhm.
Because what about the first rational number by 3? I'm just looking at it. They saying they multiply the first rational number by 3 because 3 is the 3 over 4. 3 can go into 3.
Okay, look at
Okay.
this. You change the denominator from 4 to 12. So basically, what are you doing with that denominator? You multiply it by what? What times 4 gives you 12?
3 times 4 is 12.
3. So you have to do the same thing up here. Times 3. Okay, so 3 3s are 9. Now, when you go from the 1, 6 to 12s, what are you multiplying by?
2.
So when you go from the 1 to this, you have to do the same thing, times 2. So what should be on top here? Should be
2
a
times
2,
1 is
right?
2, right?
Right. Okay. So because you changed the denominator from 4 to 12, whatever the factor is that causes you to do that, you have to use that same factor to change the numerator. So you have to multiply by 3 to get that. So you have to multiply the numerator by 3 as well. In the same way, you have to change the other denominator from 6 to 12. So whatever the factor is that you have to multiply that 6 by to get the 12, you have to multiply the numerator by that same factor. So that was 2 times 6 give you 12. So 2 times 1 give you 2. So the point of adding or subtracting fractions, if the denominator is the same, you have to make the two denominators the same. Once you make them the same, then you can now add the numerator. So 9 plus 2 is 11. That's 11 over 12. And that's your answer for that one. That can't reduce. So that's it. Okay. Now another. Okay. So that's it. Okay, so let's look at this one. What's the common denominator here?
20.
I can't.
You can't see it.
20.
Okay. Yeah. So you can use 20. Okay. So if you're changing this from 5 to 20, what factor we upping it by?
5, we're going to 24 times 1 with
Mhm. So this becomes 4 ones 4. And then when you move from 4 to 20, what factor you upping that 4 by to get to 20?
5 times,
5.
which is 50.
So you have to do the same thing to the numerator. So the numerator becomes
15.
15. All right. So the answer then would be
19 over 20.
19 over 20. Okay. All right. So in order for us to add fractions with different denominators, we have to find a common denominator and rewrite those fractions with that new denominator. But of course, it means we have to change the numerator to match. Once we do that, then we can go ahead and add. We cannot add fractions if they have different denominators unless we convert them. Okay. Now, subtracting is the same process. Okay, now sometimes it's not so easy to find a common denominator, so that's why sometimes it's good to be able to use the factor tree and the prime factorization, because in this case here, where you have 115 plus 7 over 24, the LCM is all of 120. So it's not as straightforward to easily identify it. But once you find it, then you're going to have to modify the numerators to match. But in this section, they were also looking at using the fraction key. Okay. So depending on how your calculator is set up, you can enter the same fraction in your calculator. Some fraction keys have like a L shape, and some just have the A, B/C. And so every time you punch in a number, so you type 1, then you do the fraction key, then you type 15, then you do the fraction key, then you press your minus, then you press 7, fraction key, then you press 24, equal, and then you should get the answer that they have here, which in this case is -9/40. Okay. All right, so the process of
And that 9/40 can be reduced, eh?
9/40?
No.
No, because there's no common number to divide 9 and 40.
I have a question, Mr. Allen, because when I did it on the calculator, it's giving me a -0.225.
Yeah, well, your answer is probably giving it to you as a decimal, your calculator. Now, see, do you have a fraction key on your calculator? What did you do?
I was looking for, you said it'll be A, B, and C. I have A, B over C, and I have 2 R's, and I have D over C. So I'm not sure if that is a fraction.
Okay, so you press 1, and then you press the fraction key, then you press 15, and then you press minus, then you press 7, the fraction key, then 24, and then you press equal.
Okay, I'll play around with it because I didn't put a fraction. I just put 1 divided by 15.
Oh, well, if you do 1 divided by 15, you're going to get a decimal as your answer.
Yeah, I'll have to play with it and see which one is the fraction key.
Yeah. Okay. So that's that. That's one of the problems with the remote teaching. I mean, it's convenient that you could stay at home and I could stay at home and do it, but then there are certain things that I actually need to see what you have in front of you to assist you in terms of, yeah. Okay, but if you like I say, if you play around with it, then you could or if you still can't figure it out, you could send me a screenshot through email of your calculator screen so I could see what it looks like, and then I could probably tell you which one is the fraction key. But definitely the one that says A/B over C, that is a fraction key. Okay. But if it don't work, you can let me know.
Okay, thank you.
All right, so now I'm not gonna do this one. I'm gonna skip that. Okay, so example 11 here. So the same rules that apply for order of operations with integers will also apply here when it comes to fractions. This will be on your PowerPoint when I send it to you. So I'm not going to go through it, but it's the same process. You're going to deal with the brackets. In this case, you're going to deal with the grouping symbols first. Then after you do what's in the grouping symbol, then you're going to do your exponents. Then you're going to do multiplication and division. Then you're going to do addition and subtraction. So, but it would be using fractions or rational numbers in this case. All right, so I'll skip that. And I'll just look at this last one here. Okay, so the point of using fractions, rational numbers, is to be able to solve problems, answer questions, apply them to real life situations. And so in part of your homework, we'll be getting a few of them to do. So we want to just look at this question here, which refers to a board that is 7 1/4 inches long. Is going to be, it says a board that is 7 1/4 inches long is cut from a board that is 3 feet long. If the width of the saw cut is 1/16 inch, what is the length of the remaining piece? Okay, so anybody want to tell us what we do here?
Subtraction.
Okay, it is going to be subtraction. So what are you going to subtract from what?
You're going to subtract 7 1/4 minus 1/16.
Okay.
What's left over after cutting the 1/16.
Okay, so it says a board that is 7 1/4 inches long. Okay, 7 1/4. Okay. Is cut from a board that is 3 feet long. So this is 7 1/4 inches. And then you have a piece of wood that is 3 feet. So originally, the piece of wood or board was 3 feet. But we have a piece that is 7 1/4 inches that's cut from it. Plus, we have the saw 1/16 inch from the saw was cut from that 3-foot piece of wood. So they want to know what is the length of the remaining piece. So what is the original length?
3 feet.
3 feet.
Okay. And what did we cut from the 3 feet?
7 1/4.
Okay, yeah. But we also cut something else.
1/16.
1/16, yeah, because when you, as you cut up that saw blade, also cut off 1/16. So it means you have to take 2 things away from that 3-foot length of wood. Now, this is inches, that's inches, but this is feet. So now we can't do any subtraction until all the units are the same. So we're gonna have to change which one we're gonna change?
Just into feet.
Change the,
And
Feet
just
into inches.
okay, some say the feet to inches or the inches to feet. Usually it's best to change from the larger unit to the smaller unit. So which is larger, feet or inches?
Feet.
Okay, so how many inches are there in 3 feet? How many inches in 1 foot?
12 inches is in 1 foot.
Well,
36.
Okay, so 3 would be equal to 3 times 12, which would be equal to 36 inches. Okay, so then we're going to say 36 minus 7 1/4. And then it's not just the 7, we're going to add the 1/16. So it's 2 things we have to take away from that. We have to take away, so we're going to add the 7 1/4 and the 1/16 together. And then we're going to subtract that from the 36. Okay, so what's a common denominator for a quarter and 16?
16.
16, okay. So now that's going to be 36 minus 7 4s, what's this? 28 plus 1, 29. Now in a case like this, I wouldn't, sometimes it doesn't necessarily, you don't necessarily have to convert the mixed number into improper fraction, because in this case, we're not subtracting in the brackets, we're just adding them together. So you could always put that over 16 plus over 16. So 4 times 4 gives you 16, 4 ones are 4, and this is going to remain 1/16. So when you add that together, you're going to get 36 minus 7 and 4 and 1, that's 5/16. Okay, so now that's going to be equal to 36 minus 7 and 5 over 16. So if you change, if you subtract 7 from 36, what you left with?
36 minus 7.
29,
29, I heard?
yes.
Okay. So 29. So we still have 29, and we're going to take away 5/16 from that. Okay, so we already took away 7, so we still have 5/16 to take away from the 29. How many 16s make a whole? How many 16s make a whole? Nobody? How many halves make a whole?
2,
How many quarters make a whole?
4,
Okay. How many 8s make a whole? You said two halves make a whole.
so
4
that's like
quarters.
12.
So how many 8s make a whole? That's what I'm saying. 2 halves make a whole. 4 quarters make a whole. How many 8s make a
12
whole?
and some, 12 and a
Why
half.
why you say 12 though? Because if I break up something into 8 parts, how many parts do I have? It's 8. 8 out of
Oh,
8 gives me 1 whole.
oh,
So
okay.
yeah, so I'm asking how many 16s make a whole?
1.
No. How many
16?
16 16s, right? So anytime you see a denominator like this, that's basically telling you that you have divided the whole into 16 parts. So I want now to I want to find out if I have 29 and I have to take away 5/16, then the 29, I could take away 1 from that to give me 28, and I have to take away now 1 minus 5 over 16. That 1 becomes 16 over 16 minus 5 over 16. And if I take 5 from 16, I will be left with
11.
11. So that would be 28 and 11 over 16. Okay. Now, of course, there are other ways to do it. I was trying to avoid going through finding the LCM and all of that, but we could also do it that way, where you could change this 36 into a fraction. Okay. And so if it's 36 over 1 minus 7 and 5 over 16. So we could make this into improper fraction and then convert this into a fraction where 16 is a common denominator for both of them, but it would involve some large numbers. So I was trying to simplify it by using a sort of common sense approach. You take the 7 from the 36, you'll have 29, but you still have the 5/16 to take away. So you just borrow 1 from the 29 and subtract the 5/16 from that 1, and you'd be left with 11/16. So that's 28 and 11/16. But you can do it the regular way if you wish to, or you could use your calculator and do the calculation. All right. But the main thing is to note that you have to read the question carefully and see whether you need to add, subtract, multiply, or divide. In this case, we have to subtract the piece that be cut off along with the amount that the saw would have cut off in the process of cutting to find out how much is left. So each question is different. And so you have to read it to see what is required and which operation you need to use to solve the problem. All right. So as I was going through this, I wasn't sure we'd be able to get through everything because it was quite a few slides. So I'm glad we're able to, and it seemed as if for the most part you were following, and were able to answer most, even though I think I heard someone say that they got lost a bit, but the whole presentation will be given to you. And if you have the textbook, there are examples. And for the questions that you get for homework, the answers are given to you. So if you don't get the answer that's there, then we could always discuss it next class. And I should hope that that will help you to figure out why you weren't able to get the answer. So your homework questions, 5.2, the question numbers. Most of them are very straightforward. So it's not a lot of working for some of them. So don't worry about the amount of questions you see. But and also the practice is good. Okay. You really need the practice, because some of this is stuff that you probably wouldn't have done too recently. 5.3, page 261. The questions are here. And that's that. Okay, and then your answers for the 2 sections are right here. And that's it. Now, I will get this to you in a few minutes, the presentation, and then the makeup quiz that you did. Between today and tomorrow, I should get that to you. And the quiz that you're supposed to do next, I'll send that as a makeup, and I want you to have that finished by Monday. I'm saying Monday because I prefer if you print it, answer on the printed, and send either scan it or take a picture of it and send to me. Yeah, I prefer if you do that. So I know some of you might not be able to print until you get to work. So I prefer if you print the actual thing, test and write the answers and then send it back to me by Monday evening. Okay. All right. Well, so far we have been keeping up, and I just encourage you to continue. I see a number of you have been, well, I should say all of you have been sending in your homework and trying to keep up. We have gone 4 weeks. We have 10 more to go. So we are not quite there, but getting there. And as long as you devote the time and put in the effort to do the practice, you should do well. If you don't understand something, just make sure to send some kind of communication. So, you know, to ask for assistance. Don't let it pile up, because we have so much to cover each class. And so the sooner you could get something explained to you, the better off it is for you. Okay. All right. So that's it for today, unless you have a question. I will see you next week, God's willing. Thank you very much for your attention. And that's it for today.
Good afternoon.
Okay. Okay then. Good afternoon.
Good afternoon.
Okay then. Okay.